Hello, beautiful people, and welcome to 5.4 Day 2, Triangle Congruence Day 2. So, on Monday, we went through all of our sides and angles, classified them all, trying to make sure we can write our list. We're going to use that skill real quick. So, we're going to highlight just like we did, write what you're given in order. Okay, so I'm going to keep my sides are going to be yellow again, and my angles are going to be pink. And I'm going to take a minute. I'm going to do 1 through 8, just like highlighting, okay? So given sides here, I have this side is a shared side, so it's given. I have an angle and an angle that is given. They both have that angle. We're good to go. So this example would be angle, side, angle, angle, side, angle. Because I go an angle here, a side is in the middle. He is included. He is in between the two pink ones. So he is in the middle between them. All right. No angles here because those are no parallel lines, but I have a side, and a shared side. So if I have all three sides, it's just S, S, S. Let's keep going. Sides, angle, angle. All right, that S is not included. It is not in between. So I can write either SAA or AAS, depending on the order I go, because the side is all by itself. All right, here we go. I've got a shared side, another side, and then it only gives me this one angle, so I can only assume that one angle. So that looks like a bad word to me. So I'm going to write it backwards. Side, side, angle. Let's stop there for now. All right, we can keep going. We can go through all these. Now, I'm going to tell you what these are used for. We are trying to determine right now, is ALB, so is this triangle congruent to this triangle? Is that a reflection? Are they the same triangle, same size, same shape exactly? There are some shortcuts that we can use to determine if they are going to be congruent. That is this beautiful reference sheet. We're going to spend the next 10 minutes going through this reference sheet, making sure you understand all these shortcuts, and then we will be able to use them with this skill. So here we go. To prove triangles are congruent, we originally said you need all three sides, all three angles. There are shortcuts. I need us to use these shortcuts. First shortcut, side, side, side. So if you are given this side equal to this side equal to this side, and this side equal to this side. Or if when you go through and you highlight and you end up with 3 yellows, those two triangles are congruent by side, side, side theorem. Side, side, side is a theorem. All right? Side, angle, side is a theorem. SAS is sassy. Side, angle, side is a theorem. 2 sides and an included angle. So that's a side, and an included angle. How I would write that is 1 tick mark, 1 tick mark, 2 ticks, 2 ticks, and an angle arc mark. Not an aardvark, an arc mark. So there's my angle, side, side. Y'all, it could have been any other sides or angles. So like, as long as it's included, right? So that was one example. I'm going to give you another example here that doesn't have to do with that one. Let's say it's this side, and this angle, okay? So whatever it is, as long as it has an included angle, we're good. All right, like that included angle. This one, it needs an included side. So the side needs to be in between 2 of the angles. Or the side needs to be in between 2 of the angles. Okay, these are either or. These are not congruent figures. All right, AAS is an option. So angle, angle, side. That is a side all by itself. He is lonely, lonely, lonely. So like angle, angle, and then a side. It is not included. It is not in between the A's and the A's. It is all by its lonesome. So that could be, you know, angle, angle, side, like that. As long, so it'd be an angle, and a side. An angle, and a side. All right, so as long as that side is not included, I did the same one twice, just trying to give you some very different options here, right? Like that one could work. Whatever it is, as long as that side is by himself, he is not included in between the angles and the angles. All right, you will notice the choice that is not here is bad word or bad word backwards. I am struggling with my highlighters today. If you think it might be bad word backwards, it's probably hypotenuse leg. So you will notice there is not, you know, bad word backwards. That's not a choice. That is not a shortcut. If we have SSA down here, it is not a shortcut. So like number 4, looking like a bad word backwards to me. But there is this magical one called hypotenuse leg. Hypotenuse leg is only true with a right triangle. So if I have a right triangle and it gives me a side, and a right angle, they are congruent. So it could be like bad word, angle, bad word, angle, right? So these are both, that's an S, and that's an A. That's an S, and an A. They look like they could be bad words, but they're in fact hypotenuse leg because they are right angles. If it gives you bad word backwards or bad word without a right angle, they are not congruent. My other ones that are not congruent. The shortcuts that will not work. A. Does not work. Don't use it. Don't care. Those two angles are not proven congruent. Not enough information. Or bad word. Do not use those. They do not work. Now, we know all this. We've done this. Sometimes you have midpoints that have congruent sides. Sometimes you have reflexive property that has congruent sides. Sometimes you have vertical angles, all that kind of stuff. Today, we're not talking about CPCTC. We'll get there. All right, so using that reference sheet, using those shortcuts, are these two triangles equal to each other? That is ASA. Is that one of my shortcuts I can use? Hot diggity dog, it is ASA. So I'm going to put ASA as my reason, and I'm going to write my congruency statement. So this is where we color it again. So with the A goes the M. Order matters. So M is going to go first. With the L goes the other L. And with B goes B. That is my congruency statement. ASA is my reason. SSS, that is a reason according to my shortcut. So I know that KJP, so let's check out our order here. I went K, then I went J, then I went P. So I've got to start on the back. I'm going to start on the B. So these are a little harder to figure out which ones you've got to go through first. So you don't actually want to go to the J. So you started at the empty, so I started at the empty. I went K, J, P. So K, and then I did the 2-line guy. See the 2-line? To J, to P. So the order matters. So this one, I'm starting naked. I'm starting at the empty one, B. I'm going to go to the 2-line, P. And then I'm going to go up here to J. think about it. If we had these folded on top of each other, like my B would line up with my K, but technically these angles, like they're not gonna, it's not a fold, y'all, it's a rotation. So like this lines up with this angle lines up with this angle, and this angle lines up with this angle. So it's a rotation, so you have to be careful about your order. Writing these is tough. All right, so SAA or AAS is a shortcut. AAS is usually how we write it. AAS is how we write it. So let's see, MNO, MN. So I'm going to go naked one, and then O is so I'm going to go naked angle, 1 mark, 2 marks. So I'm going to go naked angle, 1 mark, 2 marks to write my congruent statement. All right, SSA, that's a bad word, but that is a 90-degree angle. So instead of using SSA, I can use HL, hypotenuse leg. It is given me the right angle. It's given me the hypotenuse of that right angle, and it's given me a leg of the right angle. So I know that these have to be congruent. Gorgeous. So PLI, P, long side, then short side. So I'm going to start on the opposite side. The P is actually going to go with the I, long side, short side, I-E-P. These are not folded on top of each other, y'all. These are rotations. So like the top triangle is a rotation to get down to the bottom triangle. You got to be careful about what goes with what. Let's keep going. Let's mark our sides and angles. So I have a side, and then an angle and an angle. So those are vertical angles. Anything else? Don't think so. So y'all, that's bad word backwards. That's SSA, which is not a shortcut unless it's a right angle. That's not a right angle. So we're gonna put in EI for not enough information. And that there is no congruent statement because they are not congruent. You can't write it. I'm just gonna put a line through congruent. They're not congruent. Great. You can't prove it. Maybe they are, maybe it is like a reflection, but you cannot prove it given what we've been given. You'd have to be given something else. Side, 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 side. They didn't give me any angles. Y'all, not enough information. No, not enough information. I got a bunch of those going all of a sudden. Alrighty. Side, shared side, angle. So that becomes a side, angle, side, side, angle, side. If I look at just one side, remember? Side, angle, side is a choice. SAS, that is a choice. Side, angle, side is a shortcut. We can use that one. So side, angle, side. So let's see what the correct order is. GMA. So I'm going from naked to the middle, down to the A. So I'm going to go IMA. It is a reflection. It's just a mirror. So IMA is the end of my congruent statement. Side, 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 side. That is a shortcut. You can use it. Side, side, side is a shortcut. Now let's see if I write that congruent statement. GFH, so 1 tick mark, 2 tick marks. So I'm going to start again at G. Is this a reflection? This is a reflection. See, look, that is going to line up on that, so it's a little bit easier to do. So GIH is what that lines up to. All right, guys, 9 through 20 are going to be your homework. Knock it out.